Hi, so in this video, we'll be talking about determinants of matrices. Okay, so let's just explore how to calculate a determinant, and then let's talk about what potentially it represents. All right, so the first and simplest example to talk about with a determinant is if we have, by the way, we can only use square matrices to calculate the determinant. So for example, this is called a 2 by 2 matrix because there are two columns. These are the columns in blue. And then there are two rows. The rows are in red. In order to calculate a determinant of this matrix, we typically use what looks to be like absolute value bars. And so instead of using the normal matrix notation of these brackets, we're going to use bars instead. So to find the determinant of a matrix where it has the elements A, B, C, and D, there is a pattern. You do a crisscross type shape. So first you're going to multiply along the diagonal from upper left to lower right. So you multiply those two numbers, and that gives you A, and that gives you A times D. And then you're going to subtract what happens when you multiply the other way. C times D. And that's called the determinant of this matrix. So let's do a quick example of that. So if I wanted to find the determinant of, let's have, just going to make up numbers here. Let's say 3, 5, 1, -4. So I'm just going to multiply this way. And that gives you -12. And then subtract what happens when you multiply the other way. That would be 1 times 5, which is 5. And the total would be -17. Okay, let's do one more example of calculating a 2 by 2 determinant. Let's do 1, -3, 2, and 4. Okay. So take a moment, try it yourself, and then we'll check our answers. Please pause this video. Okay, so hopefully you're ready for the solution. So multiplying this way, 1 times 4 gives you 4. Multiplying the other way, remember we're going to be subtracting. So let's see, 2 times -3 is -6. So combining these, we have 4 minus -6, which is just 4 plus 6, which is 10. So this determinant is 10. As far as how we can write determinants in other forms, matrices often have capital letter names. So let's say I wanted to say matrix A was equal to 1, -3, 2, 4. Another way I can write the determinant is say I want to know the determinant of A, which would be the exact same thing as, if we didn't give it a name, we could write it like this, the determinant of 1, -3, 2, 4. This would be a less common way of doing it. Or again, that's the same thing as writing 1, -3, 2, 4, which again, we already figured out was 10. All right, so what does this actually represent? Determinants have a lot of usefulness to it, but we can actually understand what they mean somewhat graphically. This does have an actual geometry type meaning to it. All right, so let's use a program called Geogebra to understand what's going on here. All right, so let's go to Geogebra. It's just geogebra.org. And I'm going to just go to the calculator suite, so start calculator. I'm going to enter in 2 points. And the first point is just going to be the first row of that matrix. So that first row was 1, -3. So the x value is 1, the y value is -3. Let's represent that as a point. And this is a little bit weird way of looking at it. Typically, we look at matrices not as points, but as coefficients in an equation, but this is fine. This is another way to look at this. This is another purpose of matrices. All right, the second row was 2, 4, so we'll associate that with the point 2, 4. All right, so now we have these 2 points floating in space. What I want to do is I want these to actually represent line segments connected to the origin. So let me add in the origin as a point, 0, 0. All right, so what's really going on here is essentially there is a line segment. I just went to the tools option and there is drawing tools here. One of these should be a line segment option. So there's a line segment connecting this point, and then there's another line segment connecting these points. Now, these line segments can represent 2 sides of a shape called a parallelogram. So I'm going to complete the parallelogram. But to create the full parallelogram, I do need a 4th point. And the 4th point is just going to be the sum of the x values and the sum of the y values of the other 2 points. So here the x value is 1, and at point B the x value is 2. You add those together, you get 3. Sorry, let me go back to where I can easily enter in the points. So we have a point located at the sum of the x values, which is 3, and the sum of the y values, let's see, -3 plus 4 is 1. Okay, so I have another point over here. Now, let's connect all these shapes together to make a complete parallelogram. Again, going into the tools options, if you scroll down, there's more, and I want to make a 2-dimensional shape here. I'm going to make a polygon. I'm just going to connect all the points that I've already looked at. Make sure you connect back to the original point, and it'll create a parallelogram type shape. All right, so again, the parallelogram is made up of points that are essentially the rows of our original matrix that we wanted to find the determinant of. The area of this parallelogram is going to be the determinant of our matrix. Remember, our determinant was 10. If I click on this, if I scroll down here, one of the options is to find areas. Let's find that. There is a tool to find area. Here it is. So measure. If I click on area and click it, it'll tell me the area of this parallelogram type shape is 10. So that's really what a determinant represents. It represents the area of a parallelogram made up where the sides are what's called vectors, these points that we created, connecting the origin to those points. All right, I hope that kind of makes sense in a visual perspective. Now, if you think back to the first example, we had a negative determinant, and of course we can't have negative area. What that actually represents is as if we kind of distorted the whole thing and flipped it over. So that's where the negative area represents. And that might seem a little bit weird, but you know, negative area could have potential meanings, like they could represent loss, things like that. So it's a little bit interesting way of looking at things, but as long as you're having a positive determinant, it represents an area of a parallelogram. All right, so let's go on to more complicated examples where we have 3 by 3 determinants that we want to look at.